Okay, U12. This is the first of two YouTube clips that I'm going to do for polynomials, and this is to help us with exercise 5a, which is finding all the zeros of a polynomial. So what we're going to do is we're going to do example 4, which is on page 166 of Patel, and don't you hate that? And it goes like this. Given that x equals 2 is a root of the equation x cubed minus 4x squared plus 14x minus 20 equals 0, find all the other roots and hence express the polynomial in the polynomial as a product of its factors. So here we go. Here's my polynomial. X cubed minus 4x squared plus 14x minus 20. So just finish that off. So what am I going to do? Well, I know that a of x is x minus 2. So, and that's a factor. So I'm going to set up my synthetic division. I'll put a positive 2 in there because x equals 2. And then I have my 1, my negative 4, my 14, and my negative 20. And I start my division. Now remember the first coefficient is a 1. And I'm looking at this, which is the constant. It's a remainder. So 1 times 2 is 2. Add those two together. And I'll get negative 2. Negative 2 times 2 is negative 4. Add those two together, and I will get positive 10. 10 times 2 is 20. 20 plus negative 20 is 0. And that's what I wanted. So now my polynomial will be p of x is x minus 2. And what have I got here? Well, I've got x squared minus 2x plus 10. And straight away I look at this. This is a quadratic and I can do it, but my problem is I'm going to get a discriminant less than 0 because b squared, which is negative 2 squared, is going to give me 4, minus 4 times a, 1, 10, is 40. So I'm going to get 4 minus 40, which is going to give me negative 36. So when I apply this, I'm going to get complex roots. So let's do it. So we'll just do this bit here. X squared minus 2x plus 10, put it equal to 0. And I'll use a quadratic formula and I'll go x equals negative b, so that's going to be 2, plus or minus the square root of b squared, which we already know is 4, minus 4 times 10, which is 40, all over 2. And I'll get that, and it'll be 2 plus or minus root negative 36 all over 2. And I'll rewrite that as 2 plus or minus 6 times root negative 1. So over 2. The 2's will cancel. And I'll get 1 plus 3. So I get 1 plus or minus 3 root negative 1. And I can stop writing that. That's 1 plus or minus 3i. Now, let's write the p of x. So therefore, p of x equals x minus 2 x. Now, I have to go minus 1 minus 3i and x minus 1 plus 3i, because they're the roots, and I will get x minus 2, x minus 1 plus 3i, and x minus 1 minus 3i. And Patel doesn't give that because all Patel was worried about was finding the solutions. And the three solutions are x equals 1 plus or minus 3i and x equals 2. They're the three roots. And of course, we know that every cubic has three roots. These two roots are imaginary, so it only crosses the x-axis once. So what do we notice? So here's our notes. We notice we have here complex conjugates. And we already knew that. So our first bit of notes will be if one root of a polynomial is complex, and we've already done this in complex numbers. If one root of a polynomial is complex, its conjugate is also a root. And that's our first bit of our first rule, which we really already knew. So put that in your notes. If one root of a polynomial is complex, its conjugate is also a root. Now, let's have a look at the next example. Here, we don't get any of the roots. We just get given a cubic. Now, you don't have a way to solve cubics. And remember, when we started this whole 4-unit thing, that's where this all came down to. When the Italian mathematicians of the 16th century were puzzling this out, they had, Cardano had a solution to this, and he kept it secret. So there is a method for doing this, but we're not going to learn the solution to that, or the method or the formula for that, but we have another way of doing this. So let's have a look at this. If we've got, here's our polynomial. Oops, I'm still in that mode. So I've got x cubed minus 3x squared plus 4x minus 2 equals 0. We know that every cubic must have one real root. It must, because a cubic starts below or above the x-axis and ends up going the other way. So we know that there is one real root, and we're going to assume that this real root is a nice easy integer. So we want to look at this, and if there is an integer one, it has to be a factor of 2, and because there's no coefficient of the x cubed, there has to be a factor of 2. So it's either going to be 1 and negative 2, negative 1 and 2, and that's about it. That's about it. So let's try. So let's try p of 1. What do I get? I always try 1 first. 1 cubed minus 3 times 1 squared plus 4 times 1 minus 2. And that'll give me 1 minus 3 plus 4 minus 2. And that is 0. So I know x equals 1 is a solution. So again, I do my synthetic division. I put a 1 there, and what have I got? I've got a 1, a negative 3, a 4, and a negative 2. I do my synthetic division, start with a 1, and I go 1 times 1 is 1, add them together, gives me -2. -2 times 1 is -2, gives me 2. 2 times 1 is 2, 0. So I know I've done it properly. So P of X equals X minus 1, that's what my first bit was, and then I write the top polynomial, which will be X squared minus 2X plus 2. Now, I have to factorise that. And again, I'm going to realise very quickly that that's going to become 4 minus 4 times 2 is that. I'm going to get another case where this is going to give me a complex solution. So I'll just go over here. The solution to this one is going to be X equals minus B, so 2, plus or minus the square root of B squared. It's going to be 4 minus 4 times 2 all over 2. So it's going to be 2 plus or minus -4 over 2, which gives me 2 plus or minus 2i on 2. The 2's will cancel, and I get 1 plus or minus I. So my solutions are X equals 1, X equals 1 minus I, or X equals 1 plus I. And they're the three solutions. So that's pretty easy, those two questions. Remember, if one root of a polynomial is complex, then its conjugate will also be a root. And if they don't give you the roots, you're going to have to try and factor. Now, they won't always come out because a root may not be an exact integer, but for most of the purposes of the questions that you will be doing, there will be an integer root. For questions 17, 18, 19, and 20. Anyway, give those a go and then watch the next lesson.